Hey students, what's going on? Today I'm going to be talking about series and parallel circuits involving energy and electricity. There are series and parallel circuits all around you all the time, but some work better in some situations, some work better in others. So I'm going to go through a quick slideshow, and then I'm also going to present to you some ideas and how to build circuits, so that way you can see them modeled for you. Obviously, since we're on virtual learning, I can't have you building the circuits without parental supervision, so I'm going to build them here at the house, so that way you can see what we would normally do in class. Be ready to learn. Let's go. So here we go with our presentation on electricity, parallel and series circuits. What makes light bulbs brighter? So the first two terms that you really need to know are closed circuits. Electric current can flow through a closed circuit. An open circuit means that there's some kind of break in the line or that a light bulb is burned out and the electrical current cannot flow through the circuit. So, circuit diagrams. We're going to record these components and the connectors of the circuit in a simple and clear way. Trying to sit there and draw out switches and bulbs and batteries is all very confusing. So when we want to diagram in science a battery, we would just make this symbol here. Or if we have two batteries here, our wire is just going to be a clear straight line. A light bulb is a circle with an X through it, and a switch is this little diagram here that shows that the switch is open, and then when the switch is closed, this little line would be connected from circle to circle. So components of an electrical circuit, the actual circuit would look something like this if we were building it in class. We have our light bulb or our battery holder with our battery in it, which then goes to the light bulb, which then goes to the switch, and then the wire. But to draw all this out every single time for every single diagram would be a lot of work. So we use these shorthand symbols. So here's our battery, our bulb, our switch, and our wire. In a circuit, the brightness of a bulb depends on A, the number of batteries used. The greater the number of batteries, the brighter the bulb will be. And we'll diagram that there at the end. B, the arrangement of the components of the circuit. Factors that affect the light bulb's brightness is the number of batteries. If I just have a single battery, it's going to be dimmer than if I have multiple batteries in the circuit. So if I want to make a light bulb brighter, all I have to do is add more voltage to it. And in class, we use D batteries or AA batteries, also known as the LR6. So each of these D batteries that we use in class or that you use in electronics around your house are 1.5 volts. So if I have a single battery situation, I would have 1.5 volts here. And then in my multiple battery setup, I would have 1.5 plus 1.5. So this circuit here would have 3 volts compared to 1.5 on the left. Obviously, if there was 3 volts going through the single light bulb, it would be double the brightness. As more batteries are added in series, more current is available and the bulbs become brighter. When too many batteries are added, the current is so great that one of the bulbs may blow their fuse. Too much heat is made by the filament. So there's different arrangements of batteries that you can use. Batteries arranged in a parallel, so I would have these two batteries here that have their own path for electrical current, and then batteries arranged in a series, which is what we will do in class. All of our batteries will always be arranged in a series setup. It's our light bulbs that we will set up in a parallel. Batteries need to be connected with the poles in the proper direction for current to flow. Positive end of one battery needs to be joined to the negative end of another. When the number of components is the same, the bulb of the circuit with batteries arranged in a series is brighter than when the batteries are arranged in a parallel. However, if one battery is removed, only the bulb of the circuit with the batteries arranged in the parallel remains lit up. So here I have things that affect the brightness of a light bulb. I have 2 batteries in a single circuit, and it's going to make this light bulb brighter. But if I have multiple bulbs, the same amount of voltage, which we said 1.5 plus 1.5, is going to flow out the negative side and have to power these 2 bulbs, which is going to make these 2 dimmer because the voltage is being broken up between the 2 bulbs in the circuit. The greater the number of bulbs, the dimmer they are. So if I have my bulbs arranged in a parallel circuit, I have my 3 volts, and they're going to come out and they have a path that goes this way for the electrons to travel and a path for the electrons to travel like this. So if I smash this light bulb and I break this top light bulb, there will still be electrons flowing to this other battery, which means it will stay lit up. The bulbs are arranged here in a series. So my 3 volts is going to come out and go through this light bulb, and back. If I were to smash this light bulb here, this one would have to go out as well because the path for the electrons to travel through the bulb would be compromised. So bulbs in series versus bulbs in a parallel. So the arrangement of the light bulbs, which is what you guys need to know for class the most. Points of comparison. The number of paths for the electrical current. In a series, only one path for the electrons to flow. The current passes through the components one after another. So they have one path for the electricity to flow through. So in a parallel, there are 2 or more paths. And this current, the electrons get split up and passes through each branch at the same time. These paths are independent of each other. So in a series, the bulbs will be dimmer. In a parallel, the light bulbs will be brighter. If one bulb is removed from a series, the electrical current cannot flow through the circuit. The remaining bulbs will not light up. In a parallel circuit, the electrical current can still flow through the other paths, and the other bulbs will stay lit up. So even if I remove a bulb from a parallel circuit, it will still work. So a parallel is what's used in connecting circuits in your house, or twinkling lights around the holiday. Application. In a series, if all the lights in the house were connected in a series, then we would have to turn on all the lights at the same time. If one bulb blows, then all the other bulbs in the house would not light up. Hence, household lighting and wiring is arranged in a parallel. Each bulb has an individual switch to control it. Also, Christmas tree lights. Those are also set up in a parallel now. If you ever watch the old movie Christmas Vacation, the grandfather says, "Oh, you know how these bulbs are. If one goes out, they all go out." Well, that's not the case anymore because modern day lighting systems are set up on a parallel. So if one blows out, the rest of them stay lit. So just to give you another idea of this concept, is if your house was set up on a series, in order for your alarm clock to work in the morning to guarantee that you get up to come to school to see me, then you would have to have all the lights on in the house, the washer, the dryer, the oven, the microwave, the refrigerator, everything would have to be running at the exact same time, 24 hours a day, 7 days a week. All of the TVs, all the computers, anything that is plugged in at your house, if it was set up on a series, they would all have to function 24 hours a day. So let's say that your refrigerator was running and it went into like an idle state where it like shuts off. Because you hear that. You hear your refrigerator running and then it's shutting off. Well, as soon as that shut off, everything else in your house would go dark. Well, that's not functional. So everything in the house has to be set up on parallel circuits. That's why in your apartment or in your house or your townhouse or your condo, you have these giant things called circuit breakers in the basement. And that creates the multiple pathways that sends the electrical current out throughout your house. So to build my circuits today, I'm going to be using the Snap Circuit Pro kit, which we have at the school. And these things are really fantastic. I mean, kids can build all kinds of stuff from simple circuits up to like AM, FM radios. And they're built by a company called Elenco. They don't sponsor me or anything, but we use these in my classroom, and they're absolutely fantastic for showing how circuits work. Plus, it really gets the engineering mind going. So that's what we'll be using. So for our construction, we're going to have our battery pack. As you can see, the symbol that's used on here are the exact same that you saw in the slideshow presentation. In these battery packs, we have 2 of the LR6 AA's. And these blue pieces are going to serve as our wires. And they come in all different sizes in the kit. So there's 2 long, there's 3 long, there's 5, there's 6. And then these are going to serve as our light bulbs. So this is what we'll be using in order to build our circuits. All right, so the first thing I'm going to install here is my battery pack. That's going to go right here on the back. And I'm going to do a series circuit first. So now that I've completed my circuit, I have a closed circuit. So that is my simple series circuit. I have the electrons are going to flow out through the negative end of the battery. They're going to go down through my wires, through the light bulb, and on and back to the positive end of the battery. Now, if I disconnect any part of this, the light bulb goes out because there's no longer a closed circuit. Since there is a gap here, that would be considered an open circuit. And then it lights right back up. So that was by far the most easy circuit that we could build. So now what I want to do is I'm going to disconnect these. And I want to add another light bulb in here. So now I have a series that has 2 light bulbs. And you can see that they are dimmer than when I only had 1 light bulb in the series. So now I have 2 light bulbs in my series circuit, and you can see that they are noticeably dimmer. So now we're going to build this into a parallel circuit, which is going to allow the electrons to have multiple pathways to travel. So here's my parallel circuit. As you can see, both bulbs are equally bright, but they do function independently from one another. And just to display that, if I disconnect this piece here, that one light bulb down here goes out, but this one remains lit up. So if I reconnect that, you can see that both light bulbs are lit up. If I disconnect this wire here, from here to here, this light bulb goes out, but the bottom one is still lit. And you're probably asking why that is. And the main reason for that being is that in the parallel circuit, I have multiple pathways for the electrons to travel. So the energy, the electrons, is going to come out of the negative end of the battery, come to this junction, and then send electrons in this path and back up to the batteries. The other path is going to be, it's going to come down from the negative end of the battery, go down to this junction, keep going down to the bottom light bulb, and then it's going to flow back to the batteries. Now, if I disconnect this, there is no way for the electrons to get back to the positive end of the battery. Therefore, it kills all of the electrical current going through the circuit. But again, if I just disconnect here, only that bottom light bulb is going to go out, because the electrons can travel to this junction, hit this light bulb, and then come back to the battery. So these function independently of each other. And that's parallel circuit. Thanks for tuning in, everybody. To my students, make sure you're checking the Google Classroom for any updates on classes and assignments. Also, some of you might be wondering, I'm repping the alma mater, the Northview Wildcats, Northview Hockey. Always remember where you came from. Always take care of one another. And remember to wash your hands. It's a pandemic. See y'all later.